Hello everyone, I'm Farah Abdou. Today I'm going to do a presentation about enterprise AI-powered predictive maintenance platform with Azure Cosmos DB. What we are going to do today is a real-time equipment monitoring and failure prediction. So first of all, about me, I'm Farah Abdou. I'm a machine learning engineer specializing in AI and the cloud integration. I'm developing AI solutions for social impact, and I'm quantum reinforcement learning researcher. I'm here building AI and the cloud that's scalable and make some impactful solutions. So starting to our first point is an introduction to the predictive maintenance. Starting, we have a reactive maintenance. Reactive maintenance is an equipment repaired only after breakdown. After a high downtime and a high repair costs, we have the reactive maintenance as a simple approach. It's a run to failure approach. After so many years, we noticed that we have a great problem, so we converted to an predictive maintenance. And predictive maintenance is leveraging the IoT, AI, and big data analytics for real-time prediction of equipment failures. It will reduce any unnecessary maintenance action and optimizing the operational efficiency. So our solution for the reactive maintenance, we don't need to wait for the machine to break down. We are just going to the predictive maintenance so we can reduce the downtime using AI-driven insights. We have some challenges in traditional maintenance that we need to address first. First of all is the manual inspection. So manual inspection make the human is the main or the primary brain that will say like it's an error or not. So we have a huge error that's generated from humans. The second challenge is the isolated data. The isolated data can make some delayed decisions. And the third thing is that the high volume sensor data that we are generating more information that we can efficiently process. So here we have a storage and compute bottleneck. And this turns the potential insights into missed opportunities. Some of the limitations of the maintenance that we can mention is the reactive maintenance trap. So we don't need to wait for the equipment to fail. This is so costly and it leads to unplanned downtime and lost revenue. Also, some of the limitation is that in manual inspection limitation, that inspections are incomplete and inconsistent. The human limitations mean missed the warning signs. Number three is the lack of real-time insight. So if machines generate data, but it goes unanalyzed, we are missing opportunities. Number four is inefficient scheduling. So guessing leads to inefficient maintenance. This makes the optimization impossible. So as you can notice that we have traditional approaches. These traditional approaches can make the businesses fail. So this is the silent killer of industrial productivity. And traditional maintenance often fail to prevent costly unplanned failures. So a lot of companies experience unplanned equipment failures, and unplanned failures also mean a massive economic impact. So the real-time challenges demand modern and predictive solutions that we are going to present today. So we talked about machine failures, but there are more than just machine failures. We have think about the people itself. So this is not just about machines, this is about people. For people, the productivity can be losses. So unpredicted or unexpected downtime leads to significant productivity losses. This will raise the prepare costs and will reduce the team spirit. So you can notice that we have also a poorly maintained equipment that can lead to highly safety risks, and we can lose that customer trust. So if we have missed deadlines and unreliable services, this can make the customer lose trust in us. So this is our turning point. Machines now can speak before they break. So we don't need any reactive. We are going to convert to predictive. And this is the future that we can begin with. So Let's implement this with a demo that is how the predictive technologies can drive the operational excellence. Our solution overview is about turning data into predictions. We have three main points here. So we have the Azure Cosmos DB. Azure Cosmos DB is a global low latency data ingestion and machine learning, what we will be using to make some prediction model for the failure itself. And we will be using the real-time analytics with the stream processing. So as you can see, we have four steps right here, beginning with the IoT, then Azure Cosmos DB, machine learning, and a dashboard to show the results. The architecture diagram will be starting from the sensors. So I am having sensor 1 and sensor 2. This is where our raw data will be, and then I have the IoT hub, where we are going to do some pre-processing. Then our main compute is Stream Analytic Jobs and Azure Cosmos DB. Then we are going to do some Azure Machine Learning, where we are going to train our model, and then have our model presented on the Power BI. So we can see the predictive maintenance analysis. Okay, let's deep dive into Azure Cosmos DB and why Azure Cosmos DB. So Azure Cosmos DB is storing the JSON, time series, and vector embeddings in one platform, and it has a single-digit millisecond latency at any scale. So our using case right here is by storing a sensor reading every day with automatic scaling. We have here a quote from Satya Nadella, the Microsoft Chairman and Chief Executive Officer, about Cosmos DB, saying that OpenAI relies on Cosmos DB to dynamically scale their GPT services, as it's one of the fast growing consumer apps ever, enabling the high reliability and low maintenance. That's why we are using Cosmos DB today. So starting with IoT data ingestion, we have the tools that we are going to use is Azure IoT Hub, and Azure IoT Hub is a gateway that securely collects the data from the IoT devices, like the sensors in our case, and it will send it to the cloud. Next is the Event Hubs for high throughput ingestion. Our process is so simple, we just normalize and validate the data before storage. So we are just taking sensor data to the IoT Hub and then store it in Azure Cosmos DB. This is the first step. So how to set up the infrastructure tools, starting with the Azure IoT Hub. First of all, we are going to create an IoT Hub, which is the Predictive Mint Hub. Then register the devices, which we'll call the Turpin Sensor 1, and configure the consumer groups and partitions for scalability. The next step is about IoT sensor data simulations for Azure IoT Hub. In this, I'm going to establish connections to Azure IoT Hub. This is by just importing the IoT Hub device client from Azure IoT device, and then we are going to put our connection string and initializing our IoT Hub client. Then we are going to generate the realistic sensor data for monitoring. We are going to do this by continuous data generation, and we track two key matrices, like the temperature and the vibration. I have here 4 points that I have imported in my data is the sensor ID, timestamp, temperature, and vibration. And then it will be sent it to the IoT Hub and start the simulation when I say simulation or simulate sensors with the name Turpin1. The next step is that I'm going to create a database and container in Azure Cosmos DB. This will be by accessing my Azure Cosmos DB account and then Data Explorer and make or create our database and container and a partition key and then click OK. So we will be having now a database and a container in Azure Cosmos DB that we will put our sensor data in. The next step is about the real-time analytics with stream analysis. Here we are going to take the IoT Hub, Azure IoT Hub that we have created, which is a predictive Mint hub, and the output of it will be our Azure Cosmos DB database, and we're going to write a SQL query to process the streaming data. In this, we are going to make the sensor ID, average temperature, and window end. It will take it from the predictive Mint hub and store it into the sensor data container, which is our container in Azure Cosmos DB. And we are going to use the sensor timestamp for the time window and then group by sensor ID and the sampling window seconds, which is every 10 seconds. Then we are going to make or see the output aggregated data to the Azure Cosmos DB. So if we go again to our container, we can see that the data has already been parsed. After that, I'm having my data, so I need to export it for model training. So I'm going to use a Python SDK. A Python SDK here is going to use Azure Cosmos, importing the Cosmos client using the URL and the key of my account and specify the database and the container. Then I'm going to query the data and save it to the CSV. So I'm going to save it like sensor.csv. Yeah. Yeah, it's the Azan. So we can wait for 5 minutes until it ends. It's out. Okay, should I start from the slide? Okay. No problem. Like this one? Okay. Until it finished, then I will start again. Sorry for that. No, no, no problem. No problem. Okay. It's about 2 minutes or a minute, I think. So, okay. Okay, it's finished. Real-time analytics with stream analytics. So first starting with writing a SQL-like queries so we can process our streaming data. We are going to do this by input the predict mint hub and output will be the sensor data container, which is the container on our Azure Cosmos DB account. So first of all, I have here selected the sensor ID and make the average temperature and windows end. And then it will be taken from the predictive mint hub into the sensor data container. And I have used a sensor timestamp for the time window and then group by the sensor ID and sampling window every 10 seconds. The output it then will be aggregated into Azure Cosmos DB. So if I open my account again in Azure Cosmos DB and see the container, I can see that the data is imported right there. Now, with export the data for model training, we need to query the data from Azure Cosmos DB using the Python SDK. So we are going to install the Azure Cosmos, importing it from Cosmos client, and have the URL and the key or the primary key. Then we have the database and the container to be specified, and then we query the data and save it to CSV file. Now training the model. After that, we have our CSV file ready. So we are going to load it into a Jupyter notebook. And after that, we will notice that the window end is a text type. So I have converted it into a date time. And then I have created a lag features using the average temperature. After that, I am going to train a model, which is anomaly detection, using the algorithm like isolation forest or the LSTM to learn the normal temperature ranges and the flag anomalies. Now let's deploy the predictions back to Cosmos DB. So how we are going to do that by just specifying the URL, the primary key, and the client and the database, and then we are going to connect to the prediction container. So let's see this. So let's deploy the predictions back to Cosmos DB. Here we are going to initialize the Cosmos DB client with the URL, the key, and the client and database specified. We are going to make the prediction container. The prediction container here is where we will be writing our prediction to a new container. Then we are going to have new items like the ID, the sensor ID, and the average temperature, window end, and is anomaly as well. So for the ID, it will generate a unique ID to avoid conflicts, and is anomaly will update the data with anomaly flags. Then we can verify our results when we visit our Azure Cosmos DB container, new container, the predictions container. And then we will notice that we have our predictive maintenance can be done in Power BI with the DAX matrices that we have right here, the average temperature, the anomalies, the alert. And we can do also some data transformation like clean the timestamps and merge the tables. This can be done using the Power Query. Some best practices that we can do after that is with Azure Cosmos DB, we can use the time partitioning for the sensor data. We can optimize the request units per second with serverless tier and implement automatic backup to Azure Blob Storage. For the machine learning, we can retrain models weekly with fresh data and implement A/B testing for the model versioning. So overall, we have just made predictive maintenance analysis for our sensor data using Azure Cosmos DB after storing it in our IoT hub and user stream analytics. And then we have phased in and shows it in Power BI, so it will be a dashboard that we can show to anyone and make alerts. Thank you.